Lesson 3.4b is on solving exponential equations. And so sometimes whenever we're solving equations, you must use logarithms. So sometimes with exponential equations, you can get away with it without using a logarithm. I'm going to show you one of those in a second. But if things don't work out just perfectly, then you are going to need to use logarithms. So the first one, we can get away with not using a logarithm. So what we're going to do, if it's possible, the best thing to do is to try to write each side of the equation with the same base. So on this one we can. So the left side we have e to the x minus 2. And the right side we have 1 over e to the 5th. So I can write that as e to a power. 1 over e to the 5th is the same as e to the negative 5th. And then once you have that e to the x minus 2 is equal to e to the negative 5, we can just set the exponents equal and solve it for x by adding 2. And we get that x is negative 3. And that is true. If I took that negative 3 and I put it in for this x, it'd be e to the negative 3 minus 2, or e to the negative 5th, which is 1 over e, right? So if it's possible, that's the shortest way to do this problem. Now, the rest of them is probably not going to be possible. So that first bullet is what we just did. And the second bullet says if we cannot write with the same base, what we're going to do is a 4-step process to solve by using logarithms. So what we would do first is isolate the base and the exponent. All right, so if we're looking down at B and we want to do that step where we isolate the base and the exponent, the base and the exponent is this 3x. So to isolate it, you would divide by 4. And so we get 3x raised to the 12th. Now, if we could, at this point, write 12 as 3 to some power, then that would be an easier problem to do. Like if it had been 9, you could write it as 3 to the 2nd, or if it had been 27, you could write it as 3 to the 3rd, or the square root of 3, you could write it as 3 to the 1/2, but it's none of those. We can't write 12 as 3 to some power, some exact power, so we're going to have to go to the next step, which is to take the ln, or natural log, of each side. Okay, so to take the natural log, all we do is write ln in front of the 3, and we'll write ln in front of the 12th. Now, the whole purpose of doing that is so we can bring the x down. So when an x is an exponent, you cannot solve for it unless you write each side with the same base or use a logarithm to bring that exponent down. So that's going to be the power property. So for step 3, we're going to use the power property to bring down the exponent. All right, so the power property says if we have a logarithm of something raised to the power, we can bring that power down in the front. All right, and then the last step is to solve this for the variable. Now, in this case, our variable is x. Doesn't have to be x, but we are going to solve this for x by dividing by the natural log of 3. Since that's x times the natural log of 3, we divide by the natural log of 3, we get what x equals. Now, without a calculator, this is all we can do. And this is how your answer is going to be written on the challenge exam, and they know you're not using a calculator that's smart enough to do a natural log or any kind of logarithm, so they know you have to leave it in this form. The ACT is the same way. If this was an ACT question, it would also be written in this form because they know that, or all the problems on the ACT are written in a way that you can do them without a calculator. Now, I do know that perhaps your algebra 2 teacher taught you a different way to do this. Like maybe if it was 3 to the x, they would have you do log base 3 of each side and then get the answer from the calculator. And that's fine. That's right. But the answer choices on the challenge exam will be written in this way. They won't write log base 3 of 12. Now, if you remember the change of base formula, you can get the answer doing it your way. But it's just going to be extra work for you. So I would prefer that you do it this way because I know that's the format that the challenge exam is going to be written in. Okay, so let's look at another one. So for example C, the first step is to isolate the base and the power. A base and the power in this case is e to the x. So the first thing we would do would be to subtract the 7. Okay. Then we would divide by the -2. Okay. And then once you get the base and the exponent isolated, you're ready to take the natural log of each side. Now this one works out slightly different. The natural log of e becomes 1, and the left side, you're left with just the x. So x is equal to the natural log of 3 over 2. And that is how you would leave your answer. You wouldn't be expected to do anything else with it. Okay. So why don't you guys pause the video and try to isolate the base and the exponent on your own, and when you're done, start it back up. Okay. So it's 2 to the x is equal to 3. So we're trying to figure out 2 to what power gives you 3. And we can't do that in our head. The only way we can figure out is to represent it using logarithms. So we're ready to do the natural log of each side. And don't forget, the whole purpose of doing that is so we can bring the x down in the front using the power property. Okay, and then finally, we would divide by the natural log of 2. So x is equal to the natural log of 3 divided by the natural log of 2. All right, some of these are going to get slightly more challenging, but it's not too bad. On this next one, the exponent and the base are already isolated, so I'm ready to take the natural log of each side. Right, and then don't forget, the whole purpose of that is to bring this exponent down in the front. Now, because that exponent has multiple terms, you are going to want to put it in parentheses. All right. Now, at this point, if you wanted to, you could distribute the natural log, but it's so much easier if you don't. So this is x plus 7 times the natural log of 4. I want to solve that for x, so I would just go ahead and divide by the natural log of 4. And then my last step is going to be to subtract that 7. Now, we can't actually subtract it from the natural log of 5 or from the natural log of 4. It's just written at the end. That's the expression for x. All right. And then for f, to isolate the variable, there's only one thing we need to do, and that's subtract that 1. So why don't you try this one on your own? All right, so check yours with mine. Pause the video if you need to. Rewind it if you need to. All right, this next one is slightly more difficult because we have x as exponents on both sides. So that makes it a little more challenging to do. But we are going to be able to do it. It's going to take some more work. So both of our base and exponent are isolated. So we would do the natural log of both sides. And the whole purpose of doing that is to bring them those exponents so we will be able to solve for x. Now I know on that last one I told you not to distribute. On this one you do need to. So you must distribute if you have variables on both sides. So those previous ones where it wasn't a good idea to distribute, you only had variables on one side. This one is a little more difficult. So let's go ahead and distribute on the left, distribute the natural log of 3. Right? And then at this point, we're going to want to get x's on one side. All right, and then we want to factor out an x. All right, and then finally, we're going to divide by what is being multiplied by your x. Great, that looks weird. So x is equal to the natural log of 3 over the natural log of 2 minus the natural log of 3. Right. If we type that in the calculator, that would give us a decimal that we could plug in for both of these x's and get the same thing on both sides. All right, so this last one, I'm going to erase some of these old notes because they're just in my way. This last one, we are going to solve by factoring. I know it's going to feel kind of weird, but we can definitely do this. So this is a trinomial. So we're going to factor it like a trinomial, even though it has these e's in it, e to the x. So just like always, what I put here and here multiplies to give you whatever that is, e to the 2x. And what multiplies to give you e to the 2x is e to the x times e to the x. Because when you multiply those together, you would add the exponents, and it would give you e to the 2x. All right. Then, because this last sign is a plus, it tells you your signs are the same. And we are going to look here to see what it is. So these are both minus signs. All right, and what I put in the last position is going to need to multiply to give you 12, and then basically add to give you 7, since we have the same sign. So that obviously is 3 and 4. All right, so we have two little miniature equations. So we set each of those factors equal to 0 and solve for x by adding, taking the natural log of each side. Right, and then don't forget the natural log of e is 1, so it cancels out and the x drops down. So one solution is the natural log of 3. And the other solution is the natural log of 4. All right. So that's solving exponential equations. I know that's 8 examples, but they're kind of all a little bit different. All right, so your assignment is to complete these 13 problems at the bottom.